Welcome. In this video, we are going to do the explanations for the logic games that appeared on the June 2007 LSAT examination. So game 1 states, a company employee generates a series of 5-digit product codes in accordance with the following rules. The codes use the digits 0, 1, 2, 3, and 4, and no others. So the codes are 0, 1, 2, 3, 4, and no others. Each digit occurs exactly once in any code. This code is a 5-digit product code. Each digit occurs exactly once. So we have these 5 spots, and we have the 5 variables 0, 1, 2, 3, 4 that we are trying to place. Each digit occurs exactly once, so this game will be 1 to 1. The next rule says the second digit has a value exactly twice that of the first digit. Well, if the first digit was x, then the second digit exactly twice that would be 2x. Now this rule is going to allow us to make 2 deductions here, because if you notice, there's only 2 possible scenarios. First, we could have 1 go first. Exactly twice that would be 2, and that would go second. Or the only other possibility you will notice is that 2 goes first, exactly twice that, 4 goes second. Notice we can't have 3 go first because there is no 6. Obviously, can't have 4 go first because there is no 8. And you can't have 0 go first because exactly twice 0 is 0, and each digit occurs exactly once in any code. So now just checking the last rule here, the value of the third digit is less than the value of the fifth digit, so we know that the third digit must be less than the value of the fifth digit. Well, that rule allows us to conclude that 4 can't go third, because if 4 went third, what would go fifth? There is no number higher than 4, so 4, as we've demonstrated, can't go third. Same logic tells us that 0 can't go fifth, because if 0 was fifth, how could we have a lower number go third? So 0 can't go fifth. Applying that rule now to our 2 scenarios. In the first scenario here, we have the digits 0, 3, and 4 remaining. Again, we know 4 can't go in the third spot, so it can only be 0 or 3. We also know that 0 can't go in the last spot, so it can only be 3 or 4. In the second scenario, we have 0, 1, and 3 remaining. Again, we know 0 can't go fifth, so this must be 1 or 3. And now, well, we know 4 can't go third, but 4 is already placed, but 3 now is the highest digit remaining, and if 3 went third, there's no higher digit to go fifth because 4 is already second, so that tells us that 3 can't go third, making this have to be either 0 or 1. So that is our general setup for this game. As you see, we were able to make a number of deductions here, again using the rule that the second digit has a value exactly twice that of the first digit to come up with our 2 scenarios, and then filling it in using the value of the third digit is less than the value of the fifth digit. Question 1. If the last digit of an acceptable product code is 1, it must be true that the, well, let's draw a quick hypothetical here. And it tells us if the last digit of an acceptable product code is 1, so the fifth digit is 1, automatically we know we are in scenario 2, which means that 2 must come first, exactly twice that being 4 coming second. Now we know the fifth digit has to be greater than the third digit, or as they stated, the third digit is less than the value of the fifth digit. Well, since the fifth digit is 1, the only possibility for the third spot has to be less than 1, which is 0, making 3 go fourth. And the question asks, what must be true? A, the first digit is 2, and you notice A must be true, and A would be the correct answer. You notice all the other ones, B, the second digit is 0, not the case here, and if it must be true, it must always be the case, so one counterexample would eliminate that as a correct answer choice. C, the third digit is 3, again here it's 0, so that doesn't have to be true. D, the fourth digit is 4, in this scenario it is 3, so doesn't have to be true. And E, the fourth digit is 0, again does not have to be true. Question number 2. Which of the following must be true about any acceptable product code? Alright, well again, must be true, so if it must be true, it's always the case. So the nicest way to deal with these must be true questions is quickly scan for counter examples that you've already created that can help you eliminate incorrect answer choices. So A, digit 1 appears in some position before digit 2. Well, in our hypothetical from question 1, digit 1 comes after digit 2, so A does not have to be true. B, the digit 1 appears in some position before the digit 3. Again, in our same hypothetical from question 1, we see 1 after 3, so B again is eliminated. C, the digit 2 appears in some position before the digit 3. Well, that is the case in our hypothetical from question 1. 2 comes before 3, but that does not mean it must be true. Let's double check here, and you notice that there are 2 scenarios. Either 1 comes first, 2 comes second, and obviously 3 would be after 2. The other scenario being that 2 comes first and 4 comes second. Again, 3 would be after 2 somewhere. So you notice C must be true, and C is the correct answer. 2 must always appear in some position before digit 3. Question 3. If the third digit of an acceptable product code is not 0, which of the following must be true? Alright, so again, we only have 2 possible scenarios here. Scenario 1, again, we know that 1 is going to come first, exactly twice that being 2 coming second. Now, the third question is telling us that the third digit is not 0. Well, if the third digit is not 0, we know that it must be 3 in scenario 1, which means that now the only digit remaining that's greater than 3, 4 would have to go fifth, making 0 come fourth. In our second scenario, we know that 2 would come first now, exactly twice that, being 4, coming second. Now, if the third digit is not 0 in scenario 2, the third digit must be 1. The only digit remaining that's higher than 1, 3, must go fifth, making 0 go fourth. Again, looking for what must be true. A, the second digit of product code is 2. You notice in scenario 2, the second digit is 4, so A does not have to be true. B, the third digit of the product code is 3. You notice in scenario 2, the third digit is 1, so B does not have to be true. C, the fourth digit of the product code is 0, and you notice that in both of our scenarios here, the fourth digit is 0, so C must be true, and C would be the correct answer. Again, just making sure here, D, the fifth digit is 3. You notice in scenario 1, the fifth digit is 4, so D is eliminated. And then E, the fifth digit is 1. You notice that is never the case, so E is out as well. Question 4. Any of the following pairs could be the third and fourth digits respectively of any acceptable product code except. So it could be true except question, which means 4 of these are incorrect because they could be true. We are looking for the answer choice that cannot be true. So again, since we're looking for what could be true in terms of the incorrect answer choices, let's scan our previous hypotheticals and see what can we eliminate. And our hypothetical from question 1, you see that the third and fourth digits were 0 and 3. B is out. Our hypotheticals from question number 3 had 3 and 0 and 1 and 0 going third and fourth. So we know C is out and D also is out because it could be true. Which leaves us with A and E. So first, let's check A. Is it possible to have a scenario where we have 0 and 1 going third and fourth? Well, if 1 goes fourth, well, we know that the only other possibility is that 2 must come first, exactly twice that, being 4 coming second. And then the only remaining variable 3 would have to go fifth. And you notice that the third digit is less than the value of the fifth digit. 0 is less than 3. The value of the second digit is exactly twice the value of the first digit. So this does not violate any of our rules, and it shows us that A could be true, which allows us to conclude by process of elimination that E is the correct answer. And again, just to double check here, you notice it is impossible to have a scenario where 3 and 4 go third and fourth, because then we know 1 and 2 would have to come first and second, putting 0 to go fifth. And you notice the third digit here is greater than the fifth digit, 0, so that cannot be true, and E again is the correct answer. Question 5. Which of the following must be true about any acceptable product code? Again, another must be true question here. So let's use our previous hypotheticals to eliminate incorrect answer choices, because again, if something must be true, then one counterexample will eliminate an answer choice. Looking here first at A, there is exactly 1 digit between the 0 and the 1, and you notice from our previous hypothetical from question 4, we have 0 digits between the 0 and the 1, so A does not have to be true. B, there is exactly 1 digit between the 1 and the 2. And again, you notice our same hypothetical from question 4 shows us 2 digits between the 1 and the 2, so B does not have to be true, and B would be eliminated. C, there are at most 2 digits between the 1 and the 3. Well, none of our previous hypotheticals disprove C, but again, that doesn't mean it must be true. We could be missing a scenario. So let's try to come up with a hypothetical that shows more than 2 digits between the 1 and the 3. So for that to happen, they would have to be on opposite ends. And we know that if 1 comes first, exactly twice that 2 comes second. The only remaining digits are 0 and 4. And we know that the third digit must be less than the value of the fifth digit. Well, that would mean that 0 must come third, because that is the only digit remaining that is less than 3, putting 4 in the fourth spot, and that shows that it's possible to have more than 2 digits between the 1 and the 3. In that example, we had 3, so C does not have to be true. Again, C would be eliminated. D, there are at most 2 digits between the 2 and the 3. Again, going back to our previous hypothetical from question 4, we notice 3 digits between the 2 and the 3, which shows that D does not have to be true, which brings us process of elimination to E, which is obviously the correct answer here. But just to make sure, there are at most 2 digits between the 2 and the 4. Again, we know we only have 2 possible scenarios here. Scenario 1, putting 1 first and 2 second. Well, the latest 4 could go in that scenario would be last, the fifth spot, and you notice that here we would have 2 digits max between the 2 and the 4. The only other possibility, scenario 2, we know that 2 comes first, exactly twice that 4 comes second. So in scenario 2, there are no digits between the 2 and the 4. So again, proving that E must be true, there are at most 2 digits between digit 2 and the digit 4. So here we see the second game on the June 2007 LSAT exam, and it states exactly 3 films, Greed, Harvest, and Limelight, are shown during a film club's festival held on Thursday, Friday, and Saturday. Each film is shown at least once during the festival, but never more than once on a given day. On each day, at least one film is shown. Films are shown one at a time. The following conditions apply. Okay, so the first thing we know is we have 3 films, and these films are Greed, Harvest, and Limelight. Now, we are having a festival that takes place Thursday, Friday, Saturday. So Thursday, Friday, Saturday are our days. We know that each film is shown at least once during the festival. So we need minimum Greed to show up once, Harvest to show up once, and Limelight to show up once. Right? Minimum. But never more than once on any given day. Okay, so max once per day. And then it also tells us on each day at least one film is shown. So we know that each day has at least one film. So now let's go to the other conditions. It tells us first that on Thursday, harvest is shown and no film is shown after it on that day. So I know that harvest is going to come on Thursday and nothing comes after it. So it's going to be the latest film shown on Thursday. On Friday, it tells us either Greed or Limelight, but not both is shown, and no film shown after it on that day. So on Friday, we're going to have either Greed or Limelight. Again, not both. So one is in, the other would be out. And again, it is the latest film shown on that day. Nothing can be shown after it. And the last rule, on Saturday, either Greed or Harvest, but not both, is shown, and no film is shown after it on that day. Same idea, Greed or Harvest, not both, and nothing comes after Greed or Harvest on Saturday. So, I mean, really, grouping game, trying to place these movies on these days, you notice that you can come up with the maximum scenario. I mean, again, you don't really need this for the game, but I do it just to make sure we're clear on what's going on. So Thursday, Friday, and Saturday. So we could have Harvest come last on Thursday. So then we have Greed or Limelight coming before it, and we don't know which one would come first. Fine, but that's a possibility, right? On Friday, the maximum we can have is 2 because it's either going to be Greed or Limelight, the other of which would be out because of not both. The only variable remaining would be Harvest. Saturday, same idea, Greed or Harvest. One is in, the other out because, again, it says not both. And then the only other remaining variable would be Limelight. But the key here is that this is the maximum scenario. We know nothing about whether this portion is actually present. We just know we must have Harvest on Thursday. We must have either Greed or Limelight on Friday, but not both. We must have either Greed or Harvest, but not both on Saturday. No film can come after any of these films on any day. So this is the maximum scenario. But again, note that we need at least one Greed. And that's the thing, you notice we haven't actually placed Greed. So need at least one Greed. Okay, so that is our general setup. Again, we don't know much, so we're going to be very aggressive, go through these questions, apply the rules we're given, and quickly eliminate incorrect answer choices. Alright, so first turning our attention to question 6, which one of the following could be a complete and accurate description of the order in which the films are shown at the festival? So, free question, right? I don't care if you have absolutely no clue what is going on in the game. You can always get these questions right, okay? Even if your setup is completely off, because we're going to completely ignore our setup, and we're going to go through each of our rules one by one and eliminate answer choices that violate those rules. So, our first rule told us that on Thursday, Harvest is shown and no film is shown after it on that day. So we have rule 1. So let's take a look at A. On Thursday, we have Limelight and then Harvest. So A is fine. Does not violate the first rule. B, we have Harvest on Thursday, nothing else. Also fine. C, we have Harvest on Thursday, nothing else. So nothing wrong with C. D, we have Greed, then Harvest, then Limelight. So you notice that D violates the first rule by having limelight come after harvest. So D violates our first rule, so D is out. And just checking E to make sure, on Thursday we have greed, then harvest, so E is okay. So now let's go to the next rule. On Friday we have either greed or limelight, but not both, and no film is shown after it on that day. So now we have our second rule. So now let's see which answer choices violate Rule 2. So A, on Friday we have limelight. Nothing after it. A is fine. B, on Friday we have greed and then limelight. But Rule 2 says greed or limelight, but not both. B has both greed and limelight. So B clearly violates rule number 2 and therefore would be eliminated. Going to C. On Friday we have limelight. Nothing else. Nothing wrong with C. Just checking E to make sure now. On Friday we have limelight, then harvest. Rule 2 tells us we can't have anything come after limelight. Here we have harvest, so E violates rule number 2, and it is also going to be eliminated. Which brings us to our third rule here. On Saturday, either greed or harvest, but not both is shown, and no film is shown after it. So there is rule number 3. So let's take a look at A. On Saturday we have harvest. Nothing else. A is fine. Taking a look at C. On Saturday we have limelight, then greed. Also does not violate that rule. So we have a problem now. We have A and C, but don't forget about the rules that came before the conditions, and don't forget that we need each film to be shown at least once during the festival. We need at least one greed, at least one harvest, at least one limelight. When we turn our attention to A, we see limelight, harvest, limelight, harvest. Where is greed in A? So A would be eliminated, bringing me process of elimination to C, the correct answer. Now, I'm going to write the scenario from C out just so we have it, because again, don't forget, that is a free hypothetical that we can use later on. So again, we have harvest on Thursday, limelight on Friday, and then Saturday we have limelight followed by greed. So again, these questions, free points, you should never miss it. No matter what you did on your setup, ignore it because it's a nice little check as well. Go through the rules one at a time and eliminate answer choices that violate these rules. So question 7, which of the following cannot be true? So now we're looking for an answer choice that is impossible according to the rules given, right? Cannot be true. Whereas the 4 incorrect answer choices are possible or could be true. So taking a look at A, harvest is the last film shown on each day of the festival. We'll notice that on Thursday, harvest must be the last film shown, so Thursday works. On Saturday, if harvest shows up, it also must go last, according to rule 3, either harvest or greed, not both, and no film shown after it. But could harvest go last on Friday? And you notice rule 2 tells us that Friday must have greed or limelight, not both, and no film is shown after it on that day. And again, you can tell from our max scenario that we've drawn out that it is impossible for harvest to be last on Friday. So A would be the correct answer. But just making sure, let's check the rest of them. Again, looking at our max scenario that we've drawn out to see what is possible and what isn't possible. B, limelight is shown on each day of the festival. You notice we could have limelight come Thursday, Friday, and Saturday. So B could be true. So B is out. C, greed is shown on the second day of the festival. Notice we could have greed come second on Thursday, Friday, and Saturday. So C is possible. D, a different film is shown first on each day of the festival. And again, you notice from our max scenario that we could have greed come first on Thursday, harvest come first on Friday, limelight come first on Saturday. So D could be true. D is eliminated. And lastly, just checking E, a different film is shown last on each day of the festival. And again, you notice we could have harvest come last on Thursday, limelight show up last on Friday, greed come last on Saturday. So E is also possible. So E would be eliminated. Question 8. If limelight is never shown again during the festival once greed is shown, then which one of the following is the maximum number of film showings that could occur during the festival? Alright, so the key here is that we are trying to maximize. And if we're trying to maximize and they tell us that limelight can never show up again once greed is shown, we are going to hold off showing greed for as long as possible because again we're trying to maximize. And once greed shows up, I can't have limelight anymore. So turning my attention to Thursday, well, we know we could have greed or limelight or both there before harvest. But again, we don't want to have greed because if we have greed, then we can't use limelight anymore, and we are trying to maximize. So we're going to put limelight first on Thursday, followed by harvest. Moving to Saturday, now I know we're going to have one of greed or limelight, not both, and they must show up last. Maximum 2 on Friday, because one of greed or limelight is in, the other is out. Again, we don't want to use greed because it prevents us from using limelight after it. So we'll put limelight, having harvest be the first film shown on Friday. Now, bringing us to our last day, Saturday. Well, now we have to place greed because we need one of each film present during the festival. Minimum 1 greed, minimum 1 harvest, minimum 1 limelight. We haven't placed greed. We know that it's either going to be greed or harvest showing up, not both. Well, it has to be greed since we haven't used it. Harvest is out, which means that I would have limelight show up first on Saturday. So this is a valid scenario, and you notice that it quickly eliminates A, B, and C. And you notice 7 is impossible because the only day that could have more than 2 is Thursday. And you notice that to have greed come on Thursday would prevent us from using limelight again. So 7 is impossible. So D would be the correct answer. So question 9. If greed is shown exactly 3 times, harvest exactly twice, limelight exactly once, which of the following must be true? Alright, so let's figure out the possible scenarios here. Again, if greed shows up exactly 3 times, we know that greed must come every day. So, based on that, we know that greed is going to show up on both Friday and Saturday, because again, either greed or limelight, either greed or harvest, but not both. 9 tells us greed shows up exactly 3 times, so greed is on every day and greed must be last on both Friday and Saturday. Now, we know that harvest is being shown twice. Well, we know one is going to be Friday because the only other option is limelight, and since we have greed, limelight is out. So this is going to be harvest. Now, we know that we can't have harvest on Saturday because it's either greed or harvest, but not both. So Saturday must be limelight. And now we have for Friday, we know that greed is showing up 3 times, and the only thing we haven't placed as of yet is harvest, because we have to have harvest again show up twice. So this would be harvest and then greed. So, which of the following must be true? You notice, must be true. It is always the case. So one counterexample would eliminate it as an answer choice if we could find it. Because again, if it must be true, it's always the case. A, all 3 films are shown on Thursday. Well, in this scenario that we've just drawn, we only have 2 films on Thursday. So A does not have to be true, and A would be eliminated. B, exactly 2 films are shown on Saturday. Well, in this scenario, we have that, but again, we don't know if we've drawn out all of the possible scenarios, so let's hold B. C, limelight and harvest are both shown on Thursday. Again, in this scenario, we have greed and harvest, so C does not have to be true. C would be eliminated. D, greed is the only film shown on Saturday. In this scenario that I just drew, we had greed and limelight. So D does not have to be true, which brings me to E. Harvest and greed are both shown on Friday. So we're down between B and E here because we have B, exactly 2 films shown on Saturday. We have E, greed and harvest, both shown on Friday. Both of those are valid according to our scenario. So clearly we're missing a possibility. Well, B says exactly 2 films are shown on Saturday. Is it possible to have a scenario where we only have 1 film shown on Saturday? That 1 film would have to be greed, because greed shows up 3 times according to the question stem in question 9. Then obviously we know that greed comes on Friday as well. Limelight is out, so the only possibility is harvest. And then you notice we could have greed and limelight show up on Thursday. So this is the other scenario. And you notice B, exactly 2 films are shown on Saturday. In this new scenario, we only have 1 film shown on Saturday. So B does not have to be true. B would be eliminated, bringing us process of elimination to E. Greed and harvest are both shown on Friday. And you notice that must be true, as in both scenarios we have both harvest and greed shown on Friday. So E must be true, and it is the correct answer. Which brings us to the final question here on the second game, question 10, which states, if limelight is shown exactly 3 times, harvest shown exactly twice, greed shown exactly once, then which one of the following is a complete and accurate list of the films that could be the first film shown on Thursday? Alright, so we know, based on the question stem, that limelight is showing up 3 times. We know that harvest is showing up twice, and that greed is showing up exactly once. Now, the question is asking us, what is a complete and accurate list of the films that could be first on Thursday? All right, so let's take a look. Well, we know for sure that Limelight is showing up on all 3 days because it says Limelight shows up 3 times. So we know that on Friday, it's got to be Limelight, which is going to throw out Greed because not both. The only other possibility would be Harvest. We also know that Limelight must show up on Saturday, but it can't be last because it's going to be either Greed or Harvest. But we know that Harvest is showing up twice. Greed is showing up only once. So we know that Harvest must come again on Thursday, which means that the possibilities for Thursday now are Limelight, because Limelight must show up 3 times. The only remaining variable, Greed, hasn't shown up yet, must be there on Saturday. So, which of the following is a complete and accurate list of the films that could be the first film shown on Thursday? Well, we know that Harvest cannot be the first film shown on Thursday. If Limelight shows up 3 times, Limelight shows up on Thursday, and if something else shows up on Thursday, Harvest would be after it, so it's impossible for Harvest to be the first film on Thursday, which allows us to eliminate A, C, and E. So we've shown that Limelight could come first, B, so really the question is it possible to have Greed come first on Thursday? Well, if Greed came first on Thursday, again, we know that Limelight is also on Thursday, and then Harvest must be the last film shown on Thursday. Limelight, again, must show up all 3 times, so we know that Limelight comes on Thursday. In terms of Saturday, again, we know we must have Limelight because it shows up all 3 times. We also must have Greed or Harvest come on Saturday. Well, Greed shows up exactly once. We've already placed it, so it must be Harvest. And this is our other scenario, which proves to us that it's possible to have Greed come first on Thursday. So B is eliminated. So D would be the correct answer. So the third game of the June 2007 LSAT tells us a cruise line is scheduling 7 week-long voyages for the ship Freedom. Each voyage will occur in exactly one of the first 7 weeks of the season, weeks 1 through 7. Each voyage will be to exactly one of 4 destinations: Guadeloupe, Jamaica, Martinique, or Trinidad. Each destination will be scheduled for at least one of the weeks. The following conditions apply to Freedom's schedule. Okay, so the first thing we know is that this is 7 weeks. We have a linear game. We are trying to schedule these trips for this ship, the Freedom. We know that there are 4 destinations: Guadeloupe, Jamaica, Martinique, and Trinidad. We also know that each destination will be scheduled for at least one of the weeks. So each of these must show up at least once, minimum. So that's 4 of our weeks. Now 3 are left open that we can fill with these variables. We have no idea which ones can possibly go where yet. So this is our general setup as of now. So now let's look at the conditions. The first rule tells us Jamaica will not be its destination in week 4. So we know that Jamaica won't be coming in week 4. The next rule tells us Trinidad will be its destination in week 7. So now we've placed Trinidad. It's possible Trinidad shows up again, but at least once, and there's the at least once in week 7. It then tells us Freedom will make exactly 2 voyages to Martinique, and at least 1 voyage to Guadeloupe will occur in some week between those 2 voyages. Alright, so now we know that Martinique is not going to show up just once, it's going to show up twice. Exactly twice. And at least 1 trip to Guadeloupe is going to come in between the 2 trips to Martinique. So we have that rule now. The next rule tells us Guadeloupe will be its destination in the week preceding any voyage it makes to Jamaica. So, if we have Jamaica, any, right, introduces sufficient, then we know Guadeloupe is in the week preceding. Well, we have Jamaica at least once. We know that. Each of the destinations will be scheduled for at least one of the weeks. So since we have Jamaica, we know that for sure we have Guadeloupe coming before it, which tells us that Jamaica cannot come first. Because if Jamaica came first, there's no week preceding it. How could you have Guadeloupe in the week preceding? This rule also tells us something else, and that is that the maximum number of times we can have Jamaica is 2. Because if you notice, if you had 3 Jamaicas, you would have to have 3 Guadeloupes. That is 6 of the 7, but still have M and T. So you notice the maximum number of trips to Jamaica is 2. And then the last rule tells us no destination will be scheduled for consecutive weeks. Well, we can't have Guadeloupe, Guadeloupe. We can't have Jamaica, Jamaica. We can't have Martinique, Martinique. And we can't have Trinidad, Trinidad. Well, since we know Trinidad is in week 7, can't go consecutive weeks, tells us Trinidad cannot be in week 6. And that is the general setup for this game. Question 11. Which of the following is an acceptable schedule of destinations for Freedom in order from week 1 through week 7? So, free point. We know we're going to ignore our setup completely. We're going to go through the rules one by one and eliminate answer choices that violate those rules. So the first condition was Jamaica will not be its destination in week 4. In A, we do not have Jamaica in week 4. In B, we do not have Jamaica in week 4. C is okay. D, you notice, however, we have Jamaica in week 4. So D would be eliminated, again, directly violating the first rule. Rule 2. Trinidad will be its destination in week 7. A is fine, as is B, C, D is already eliminated. And you look at E, we see Martinique in week 7, which violates the second rule, so E would be eliminated. The next rule, Freedom will make exactly 2 voyages to Martinique, with at least 1 voyage to Guadeloupe in between those 2 voyages. So we look at A, 2 trips to Martinique, Guadeloupe in the middle, A is fine. B, we have 2 trips to Martinique, but the only thing between it is Trinidad. Where is Guadeloupe? So B violates the 3rd rule, and B would be eliminated. C has 2 trips to Martinique with a trip to Guadeloupe between it, so C is fine. Which brings me to the 4th rule. Guadeloupe will be its destination in the week preceding any voyage it makes to Jamaica. Well, you notice A is fine. We have Jamaica in week 2. The week preceding is Guadeloupe. C, however, has Jamaica first. We know that that is impossible as it violates that condition because we have to have Jamaica. So C would be eliminated, which brings us to A, the correct answer by process of elimination. And again, we're going to write out the scenario in A because let's not forget that that is a free hypothetical that we can use as we proceed. So Guadeloupe is first, followed by Jamaica, then Martinique, Trinidad, Guadeloupe, Martinique, and Trinidad. Question 12. Which of the following cannot be true about Freedom's schedule of voyages? Alright, so looking for a cannot be true answer choice, something that is impossible given our rules, whereas the 4 incorrect answer choices are possible. We look at A, Freedom makes a voyage to Trinidad in week 6, and we know that that is impossible because Trinidad comes in week 7, and we cannot have Trinidad show up in consecutive weeks, so A would be the correct answer. Question 13. If Freedom makes a voyage to Trinidad in week 5, which of the following could be true? Alright, so let's take a look here and see what happens if Freedom takes a voyage to Trinidad in week 5. Well, we already know Trinidad shows up in week 7. Now it is also going to come in week 5. Okay, so now the best thing to do is think about what else is very restrictive. And obviously we have these 2 trips to Martinique with this Guadeloupe trip sandwiched in between it. Because what you see is that you could have 1 variable between them, 2 variables between them, 3 variables between them, right? As many as 5 variables between them. Obviously not in this case, but we could have 4. But if you notice, we do know something about Jamaica. Jamaica can't come 4th, can't come 1st. So there's really only 2 possibilities for Jamaica. One is in week 3, which would make Guadeloupe come 2nd. The other possibility would be that Jamaica comes in week 2 with Guadeloupe showing up in week 1. Again, we already know Trinidad's in week 5 and 7. So now we can try to place our trip to Martinique. You notice that Martinique in the first scenario where Jamaica is in week 3 and Guadeloupe is in week 2, well, M has to be 1 or 4 or 1 or 6. So you notice either of those scenarios, M for sure is going to be in 1. Now we know Jamaica can't go in 6, Trinidad can't go in 6, so it has to be either Martinique or Guadeloupe. In the other scenario, again, you notice the only possibility now is Martinique must come in weeks 3 and 6, with the one trip to Guadalupe showing up in week 4. So those are our two possibilities. We're looking for what could be true. A, Freedom makes a voyage to Trinidad in week 1. Impossible, either Guadalupe or Martinique. B, Freedom makes a voyage to Martinique in week 2. Again, impossible, either Jamaica or Guadalupe. C, Freedom makes a voyage to Guadalupe in week 3. Again, impossible, either Martinique or Jamaica. D, Freedom makes a voyage to Martinique in week 4. And you notice that that is possible. We could have Martinique in weeks 1 and 4 in the scenario where Jamaica comes in week 3, so D could be true. You notice E, Freedom makes a voyage to Jamaica in week 6, impossible. We already know that because any week preceding Jamaica must be Guadalupe, and they've told us Trinidad shows up in week 5, so E is out, and again, D would be the correct answer. Question 14. If Freedom makes a voyage to Guadalupe in week 1 and a voyage to Jamaica in week 5, which one of the following must be true? Alright, so we'll draw out our hypo here. Again, we already know Trinidad is going in week 7. But now it tells us Freedom is going to Guadalupe in week 1 and Jamaica in week 5. We know that anytime we have Jamaica, the week preceding it must have Guadalupe. Now the question is, what is going to happen to our two Martiniques? And you notice they can't both show up in 2 and 3. One of them is going to be in 2 or 3. The other has to be in 6. We can't have Guadalupe show up in weeks 2 or 3 because they can't be consecutive. So the only possibilities for week 2 are Jamaica, Martinique, or Trinidad. You notice that for week 3, if week 3 was Jamaica, week 2 would have to be Guadalupe. So we know that Jamaica can't come in week 3. So the only possibilities for week 3 would be Trinidad or Martinique. So now again we're looking for what must be true. A, Freedom makes a voyage to Jamaica in week 2. No, could be Martinique or Trinidad. B, Freedom makes a voyage to Trinidad in week 2. Again, could be Martinique or Jamaica. B is out. C, Freedom makes a voyage to Martinique in week 3. Could be Trinidad, so C does not have to be true. D, Freedom makes a voyage to Guadalupe in week 6. That is impossible. It must be Martinique, which brings us process of elimination to E. Freedom makes a voyage to Martinique in week 6. And you notice that must be true, so E would be the correct answer. Question 15. If Freedom makes a voyage to Guadalupe in week 1 and to Trinidad in week 2, which one of the following must be true? So again, let's draw out a hypothetical here. Again, we already know Trinidad comes in week 7. Question 15 now tells us Guadalupe is going to be our destination week 1. And Trinidad is also going to show up again in week 2. So now, let's try to place Jamaica and our two Martiniques. We know Jamaica cannot show up 4th. We also know that it cannot be 3rd now because the week preceding the 3rd week is Trinidad, can't be Guadalupe. So the only two possibilities right now for Jamaica are 5 and 6. If Jamaica showed up in week 5, we know the week preceding it must be Guadalupe. And then obviously our trips to Martinique would show up weeks 3 and 6. One trip to Guadalupe between them, that is fine. Again, the other possibility we saw was that Jamaica shows up in week 6. Again, that would put Guadalupe in week 5. placing what we know already. Now, Trinidad now is in week 2, which would put both Martiniques in week 3 and week 4, which is an invalid scenario, so that is out. Again, we're looking for what must be true. A, Freedom makes a voyage to Martinique in week 3, and you notice in week 3 we have Martinique. A must be true, and A would be the correct answer. You notice the rest of these. B, Freedom makes a voyage to Martinique in week 4. No, Guadeloupe. C, Martinique in week 5. Here it's Jamaica. D, Guadeloupe week 3. Again, has to be Martinique. And E, Guadeloupe in week 5. Again, week 5 must be Jamaica. Question 16. If Freedom makes a voyage to Martinique in week 3, which one of the following could be an accurate list of Freedom's destinations in week 4 and week 5, respectively? Alright, so again, we are going to draw out a hypothetical here, placing what we know, Trinidad in week 7. It now tells us Martinique is going to be our destination in week 3. Well, we already know that Jamaica cannot be our destination in week 4, which automatically eliminates B. We also know that we can't have the same destination in consecutive weeks, which would eliminate C. And we also know that when we have Jamaica, the week preceding it must be Guadeloupe, so D would be out because the week preceding Jamaica in D is Trinidad. So down to A and E, is it possible to have a situation with Guadeloupe in Trinidad in weeks 4 and 5? Well, we still have to place Jamaica. The only possible place for Jamaica now is in week 2. Can't go in week 6 because Trinidad is in week 5, which makes Guadeloupe have to show up in week 1, making Martinique show up in week 6. That does not violate any of our conditions, so A is the correct answer. So A is the correct answer. You notice E, if we had Trinidad and Martinique show up 4th and 5th, that would violate the rule of having at least one Guadeloupe between our trips to Martinique. Which brings us to question 17. Which of the following must be true about Freedom's schedule of voyages? This is a perfect time trap question because we don't really have any deductions, right? We've made deductions that Jamaica can't come first. Trinidad can't be our destination in week 6. But other than that, the only other deduction we've made is that Jamaica can show up maximum twice. That is the correct answer here. If you look at D, Freedom makes at most 2 voyages to Jamaica. But again, our strategy on a question like this would be, we would quickly scan the answers. So we would start with A, Freedom makes a voyage to Guadeloupe either in week 1 or else in week 2. Again, they're saying what must be true. So we would look back at our previous hypotheticals, question 11, 13, 14, 15, and 16 to see if we could disprove one of these statements. Again, if something must be true, then one counterexample would eliminate it as a possible answer choice. Unfortunately, when you look at our previous hypotheticals, we have Guadeloupe in either week 1 or week 2 in all of them, so we can't eliminate A. We would move on to B. Freedom makes a voyage to Martinique either in week 2 or else in week 3. And again, when you look at our hypotheticals, we have Martinique in either week 2 or week 3, except for in our hypothetical in question 13, where we had Martinique show up in week 1. So B would be eliminated. Again, one counterexample eliminates an answer choice on a must-be-true question. C, Freedom makes at most 2 voyages to Guadeloupe. Again, we don't have a counterexample to that, but that does not mean it must be true. So moving on to D, and you notice now we would arrive at the correct answer. Freedom makes at most 2 voyages to Jamaica. Again, we know that must be true from our deduction that we made in our original setup. so D would be the correct answer. So again, on time trap questions like this, remember, scan the answer choices, and if you can't eliminate it, don't try to sit there and prove that it must be true. There's no reason to do that. Look to see if you can maybe find an answer choice before going through that painstaking process. Which brings us to the last game, Game 4 of the June 2007 LSAT, and it states, there are exactly 3 recycling centers in Rivertown, Center 1, Center 2, and Center 3. Exactly 5 kinds of material are recycled at these recycling centers: glass, newsprint, plastic, tin, and wood. Each recycling center recycles at least 2 but no more than 3 of these kinds of material. The following conditions must hold. Alright, so we know we have 5 kinds of material: glass, newsprint, plastic, tin, and wood. We have 3 recycling centers, centers 1, 2, and 3, and they must recycle at least 2 but no more than 3. So max 3. Alright, so let's take a look at the conditions. The first rule says, any recycling center that recycles wood also recycles newsprint. We know any, just like each, every, all, introduces sufficient. So if you recycle wood, you must recycle newsprint. Contrapositive, if you don't recycle newsprint, then you can't recycle wood. Rule 2. Every kind of material that Center 2 recycles is also recycled at Center 1. Again, we know every, just like any, each, all, introduces sufficient. So if you are recycled by Center 2, you must be recycled by Center 1. Contrapositive, if you are not recycled by Center 1, you cannot be recycled by Center 2. And you notice that this lets us come up with a couple of scenarios here, because notice that it's possible that Center 2 either recycles 2 or 3 materials. And if Center 2 recycles only 2 materials, we know that Center 1 is going to share those exact same materials. It's also possible that Center 2 recycles 3 materials, in which case Center 1 would also recycle those exact same 3 materials. But you notice it is possible for Center 1 to recycle a 3rd material in the scenario where Center 2 recycles only 2 materials, because Center 1 is necessary, so it's possible for something to be recycled in Center 1 and not in Center 2. So now checking the last rule here tells us only one recycling center recycles plastic, and that recycling center does not recycle glass. So we have only one plastic, and that center does not recycle glass. Contrapositive, if you recycle glass, you cannot recycle plastic. And you notice that allows us to come up with another deduction, because if plastic were to show up in recycling center 2, the second rule tells us that it must also show up in recycling center 1, which violates the third rule that there is only one center that recycles plastic. So we know from that center 2 cannot recycle plastic. We know we only have one plastic, and it must be showing up in either recycling center 1 or recycling center 3. And that is the general setup for this game. Question 18. Which of the following could be an accurate account of all kinds of material recycled at each recycling center in Rivertown? So again, we're going to ignore our setup, go through the rules one at a time, and eliminate any answer choice that violates these rules. So the first condition, any recycling center that recycles wood also recycles newsprint. Well, we look at A, center 1 has wood, has newsprint. Center 2 has wood, has newsprint. Center 3 has wood, but where is newsprint? So A violates the first rule, so A would be eliminated. Checking the other ones, B, center 3 has wood, also has newsprint, fine. C, center 1 has wood, has newsprint. D, center 3 has wood, has newsprint. E, center 1 has wood, has newsprint. Center 2 is also fine. So moving on to the second rule. Every kind of material that center 2 recycles is also recycled at center 1. So looking at B, center 2 has glass, newsprint, tin. Center 1 has glass, newsprint, tin. B is fine. C has glass, newsprint, tin. Center 1 has glass, newsprint, wood. So you notice there, center 1 is missing tin. So C would be eliminated. Again, directly violating the second rule. Moving on to D, center 2 has glass, tin. Center 1 has glass and tin, that's fine. E, center 2 has newsprint, plastic, wood. Center 1 has newsprint, plastic, wood. So let's move on to the third rule. Only one center recycles plastic. Well, you notice that in E, we have plastic showing up twice. So E would be eliminated, violating the third rule. And then looking at B and D, B, glass is not with plastic, only have one plastic. D, in center 1, we have glass and plastic together. So D would be eliminated, again, directly violating the third rule, which brings us process of elimination to B, the correct answer. The free hypothetical from answer choice B, just because we want to make sure that we have it going forward. It could be useful. And again, center 1 recycles glass, newsprint, and tin. Center 2 recycles glass, newsprint, and tin. And center 3 recycles newsprint, plastic, and wood. Question 19, which of the following is a complete and accurate list of the recycling centers in Rivertown, any one of which could recycle plastic? Well, again, we know that center 2 can't recycle plastic, which would eliminate C and E. We also know from our free hypothetical in question 18 that center 3 can recycle plastic, so A would be eliminated. And obviously nothing is stopping center 1 from recycling plastic, so D would be the correct answer. Question 20. If center 2 recycles 3 kinds of material, then which of the following kinds of material must center 3 recycle? Well, we know that if center 2 recycles 3 kinds of material, center 1 is going to recycle those exact same kinds of material. Coming from the second rule, every kind of material that center 2 recycles is also recycled at center 1. We know plastic cannot be in center 2, which means that if center 2 has 3, plastic cannot be in center 1 either. Plastic shows up once, which tells us plastic must show up in center 3. The question is asking us which of the following kinds of material must center 3 recycle, and the correct answer would be C, plastic. Question 21. If each recycling center in Rivertown recycles exactly 3 kinds of material, then which one of the following could be true? So again, we're in the scenario where we have all 3 centers recycling exactly 3 materials, which means that centers 1 and center 2 are recycling the exact same set of materials, which again tells us that plastic cannot come in centers 1 or centers 2, which means that plastic must show up in center 3. We know that that means glass cannot be recycled in center 3, which means glass must be in centers 1 and 2. Now, who do we have left to place? Well, we can't use P anymore. Plastic is out, so we have N, T, and W. And you notice that if you have W, you must have N. And the only other possibility then would be to have N with T. But you notice N is in both of those scenarios, and then it would be either T or W. Same exact options for center 3. And notice that these must be the same. Either both are tin or both are wood, again because centers 2 and 1 must recycle the exact same set of materials. So looking for what could be true, A, only center 2 recycles glass, impossible. Anything center 2 recycles must be recycled in center 1. B, only center 3 recycles newsprint, again, impossible. We know newsprint must show up because we don't have enough variables to fill up the spots in centers 1 and centers 2 without newsprint. C, only center 1 recycles plastic. Again, we know center 1 can't recycle plastic, so C is out. D, only center 3 recycles tin. And you notice that is possible. We could have center 3 be the only center that recycles tin. Centers 1 and 2 could both recycle wood. So D could be true, and D would be the correct answer. And again, you notice E, only center 1 recycles wood. Impossible. Centers 1 and centers 2 must recycle the exact same set. So E would be eliminated. Question 22. If center 3 recycles glass, then which one of the following kinds of materials must center 2 recycle? So looking at this question now, center 3 recycles glass, then which one of the following kinds of materials must center 2 recycle? Well, we know if center 3 recycles glass, we cannot have plastic come on center 3. We also know that plastic can't be in center 2, which means plastic must show up in center 1. That means glass cannot be in center 1. So now, glass can't be in center 1. If you can't be in center 1, can't be in center 2. We know center 2 must recycle at least 2 materials, just as must center 1 and center 3. The variables remaining are N, T, and W. And again, we know from before that there's only 2 possible scenarios there. So N must be present, and then tin or wood would be the other variable. So what must center 2 recycle? B, newsprint. Which brings us to question 23. If center 1 is the only recycling center that recycles wood, then which one of the following could be a complete and accurate list of the kinds of materials that one of the recycling centers recycles? Alright, so let's draw out this scenario and see what we can come up with. Again, we already know that plastic can't be in center 2, but now it tells us that recycling center 1 is the only recycling center recycling wood. Well, Automatically that tells us wood can't go in centers 2 or 3, which tells us that we're in the scenario where center 1 has 3 materials and center 2 has only 2 materials. Because again, if center 1 is the only center that recycles wood, centers 1 and 2 can't have all the same materials, which means center 2 cannot recycle 3 materials, because then center 1 would have to have those exact same 3, and that would violate this idea that only one center, center 1, recycles wood. We know that if you have wood, then you have newsprint, so we can place newsprint. Well, now we know newsprint must also show up in center 2 because the remaining variables must be the same. We know that center 1 cannot recycle plastic now because the variables have to be equal for the remaining 2 to satisfy the rule that any material recycled by center 2 is recycled by center 1, which tells us that plastic must come in center 3, which tells us that we cannot have glass. Only options remaining are newsprint and tin. And now you notice we still need to place glass, and we know that the remaining spots are going to be the same for centers 2 and centers 1. So here is the scenario. We're looking for what could be an accurate list, complete an accurate list of the kinds of materials that one recycling center recycles. A, plastic and tin, and you notice that is possible, shown in center 3, so A would be the correct answer. You notice newsprint and wood, impossible. We also must have glass in center 1. C, newsprint and tin, no. D, glass and wood, again, we must have newsprint in center 1. E, glass and tin, never possible.